What would happen if the person sitting next to you sneezed on you? You'd worry about getting sick, right? If it were a dog that sneezed on you instead, you wouldn't worry at all. But should you? Most new human viruses were once animal viruses that mutated and became able to infect us. So what's to stop your dog's viruses from becoming the next Ebola epidemic? One of your biggest protections is your receptors. Receptors are pieces of protein or sugar stuck to the surface of a cell. Viruses use receptors to stick to cells and enter them, starting an infection. Most of the time, your receptors are different enough from your dog's receptors that dog viruses can't stick to your cells. And if a virus can't stick to a cell, it can't infect it. But what happens when viruses can stick? What protects you then? What else besides receptor binding do viruses need to infect you? To answer this question, I work on canine parvovirus. Canine parvovirus started off as a cat virus that mutated and became able to infect dogs. So it's already jumped from one host to another once. But what makes this virus really weird is that it can bind to our receptors and enter our cells, but it can't infect us. And furthermore, if you take the dog receptor and put it on something like a hamster cell, the virus can infect that cell where it couldn't before. So clearly, canine parvovirus needs something special from its receptor in order to infect cells. But if that special something isn't just binding to the cells, what's going on here? So I made mutations to canine parvovirus on the spot that's responsible for binding to the receptor. And eventually, I found a mutant that could stick to the dog receptor and enter dog cells, but couldn't infect them, just like what we see in humans. I could show that the mutations I made changed the shape of the virus, but that the strength of binding between the virus and the receptor had not changed. So what's going on here? All the evidence I've collected points to something called a conformational change. Viruses are made up of protein building blocks, kind of like small origami pieces that get assembled into a whole. If you pull on one of those origami pieces, the other pieces get pulled on as well, and the shape of the whole origami changes. When canine parvovirus binds to the dog receptor, it's like the dog receptor is pulling on it, changing its shape and activating it. When canine parvovirus binds to the human receptor, or if it's been mutated, the receptor can't pull on it the right way, so the shape doesn't change and it doesn't become activated. By understanding the conformational change, we can look for similar viruses in the wild to see if they're mutating in ways that might allow them to infect us. And we can also develop antiviral drugs to block infection if those viruses actually ever are able to infect us. Thank you.